Assalamu alaikum and welcome to another video. This video is for the students of class 9-10 English version, and in this video I'll try to discuss very basic topic of chapter 4 of physics, and the name of the chapter is work, power and energy. At first we will learn about work. What is work and what is the definition of work? Dear students, you can define work in so many ways. I have written here a simple definition that when a force causes a displacement of an object, then it is called work. Now we have to focus on two quantities here. We can see here two quantities. First one is force and second one is displacement. Okay. To get work, we have to apply force on any object, and this object have to travels a distance or displacement. So we can tell work is equals to force into displacement. In another way, we can tell the product of force and displacement is called work. We can express work by the letter of W and force by F and displacement by S. That means we can tell W is equals to Fs. This is the formula to get work from given information, force and displacement. Now, what type of quantity is work? Work, it is a derived quantity, because to get work we need to know force and displacement, and we know the quantity which obtained from more than one quantities. This is called derived quantity. So work is a derived quantity. So you can note it down that work is a derived quantity. Now another question, is the work vector quantity or scalar quantity? Answer is work is a scalar quantity. But why? We know the product of two vector quantity is a scalar quantity. Here force it is a vector quantity, displacement it also a vector quantity. As we know, product of vector quantities is a scalar quantity. Work is the product of force and displacement, and both force and displacement is a vector quantity. That's why work is a scalar quantity. Work is a product of two vectors. That's why work is a scalar quantity. Maybe all of you have learned about scalar quantity and vector quantity earlier. Scalar quantity needs only magnitude to express, but vector quantity needs both magnitude and direction to express. Now let's learn about the unit of work. We have got here work is equals to force multiply displacement. And we know the unit of force is Newton, and it is expressed by N, and the unit of displacement is meter, and it is expressed by the letter of M. So the unit of work will be Newton meter. Newton meter. But Newton meter, it is a derived unit of work. It has another unit to express, and this one is joule. Newton meter and joule are same. 1 Newton meter is equals to 1 joule. Work has another unit to express, and this one is calorie. And 1 calorie is equals to 4.184 joule. Sometimes it is written that 4.2 joule, and its short form calorie is written CA. That's why we can tell 1 CA is equals to 4.18 joule. if we want to convert joule into calorie, then it will be 1 joule is equals to 0.24 calorie. Okay, and this is about the unit of work. How to determine the amount of work? As we have learned, work is equals to force into displacement. That's why you can tell if 1 Newton force is applied on any object and if the object travels 1 meter distance, then the amount of work will be 1 joule. Because work is the product of force and displacement, here force is 1 Newton, that means 1, then multiply, displacement is 1 meter, that's why 1, so 1 multiply 1 is equals to 1. And we have learned that 1 Newton meter is equals to 1 joule. Here 1 Newton multiply 1 meter, so 1 Newton meter is equals to 1 joule. So to get work, we will multiply the amount of force with amount of displacement, then we will get the amount of work. Now let's learn another important topic of work, and this one is dimension of work. To determine the dimension of work, at first we have to apply the formula whatever we have got before, and this one is work is equals to force into displacement. Here displacement, it is a fundamental quantity, but force, it is a derived quantity, because we know force F is equals to ma. That means force is the product of mass and acceleration. So instead of force we can write mass into acceleration. Instead of force we can write mass into acceleration, and displacement is here. Now another thing, mass, it is a fundamental quantity, displacement also fundamental quantity, but acceleration, it is a derived quantity. And we know acceleration A is equals to velocity by time, v by t. Okay, acceleration is equals to velocity by time. But you can think that we know acceleration is equals to v minus u by t, but I have written here velocity by time. But why? Because change of velocity, it is also a velocity, right? Change of velocity also a velocity, that's why we can tell acceleration is equals to velocity by time. So instead of this acceleration we can write velocity divided by time. So instead of acceleration we can write velocity by time. Now another thing, mass, time and displacement, all of them are fundamental quantity, but velocity, it is also a derived quantity. And we have learned that velocity is equals to displacement by time. So instead of velocity we can write displacement divided by time. So instead of velocity we can write displacement divided by time, and time, previous time is here, mass and displacement. Now it is a fractional division, we can write it like this way, mass into displacement is as a numerator, and the denominator of numerator will multiply with the denominator of the main fraction. That's why time multiply time, this time multiply this time, and numerator will be displacement, then multiply again displacement. Now here it will be time multiply time, that means time square, and displacement multiply displacement will be displacement square. So we can write like this way. Now if we want to express mass, displacement and time by letter, then how can we express? We express the mass by m, then multiply displacement by capital letter L, because displacement means length, right? So instead of displacement we can write length, and square is here. Then instead of time we will write capital letter T and square. And to express dimension we need to write all of the letters in capital form. Okay, now mass length square divided by t square, and we know if we want to write it with them, then the power of denominator will be negative, then it will be t inverse 2, and mlt inverse 2, it is the dimension of work. My dear students, hope all of you have understood about work. In my next video, I'll try to explain about energy and power.